All right, welcome back to Ozark Garage. Today we're going to make some upgrades to our mini mill here. So this is a Rong Fu RF31. This is what's called a mill drill because it has a round column similar to a drill press, but it does have an R8 spindle like a regular Bridgeport milling machine would, and it's got a cross slide table so you can actually do milling operations and cutting, side cutting with an end mill. And it's a pretty handy size, so it's not a full-size Bridgeport, which would be nice, but it is large enough to be able to do a lot of things I need to do with it, which by far and large is make the wrong parts fit. And that's the answer I kind of give people when they ask me, oh, what do you do with the mill? And it's like, I have a part that I bought from somewhere, and it doesn't fit and needs to be modified, so I will make some cuts on it. I do some fabrication with it, so I will make brackets and tabs and that sort of thing when I need to. But otherwise, it's just for modification of a lot of stuff. The RF31 is sold under a lot of house brand names, so I've seen these sold under the Jet brand. I've seen these sold under the Grizzly brand. In fact, it's so similar to the Grizzly G0705 that that's what I use for my quick reference for speeds by swapping the belt. So overall, I have very few complaints with this machine. This top cover here is kind of annoying because you can't access the draw bolt up top with it installed, with it closed anyway. So you have to open it and then it always falls off. So it pretty much lives like this all the time, so I have access to the draw bolt and the top of the spindle. This machine does have forward and reverse, so I know a lot of the Grizzly ones that I've seen don't have forward and reverse, so that's a little nice feature of this actual Rong Fu version, if you will. So what we're going to do today is we're going to install what's called a DRO, or Digital Readout, and that pretty much is what it says it is. So a Digital Readout uses electronic linear scales like this to read its actual position, either from where you start to where you stop, or an overall position, and displays that position on a digital readout like this. And so this will mount to the side of the machine, probably somewhere over here, and this will allow me to be a lot more precise with the machine. These linear scales are universal, which means they fit nothing. So we're going to make them fit our Rong Fu RF31. So a typical vertical mill is what's known as a 3-axis machine, meaning it's got 3 axes of movement. So you have the X, which is the cross slide this way, you have the Y, which is the cross slide this way, and then you've got the Z, which is the height. The X and Y axis both have dials on the cranks, but there's always backlash in them and they're still not super accurate. And if you want to go over multiple inches, your multiple rotations of the dial, so the DRO will be much more accurate than these. So I've got 3 different scales, 3 different lengths. This is the medium length one. This one will be for the Y-axis, which is this way here. It'll get mounted on the side. But I'm going to mount these in order of, least difficult to mount to most difficult to mount. So I'm going to do the X-axis first, and then I'm going to do the Z-axis last. All right, so this is the cross-slide table, and this will be where I'm going to mount the X-axis linear scale. I've looked at how other people have mounted DROs to these type of mills, and a lot of people seem to mount them on the back side of the table so they can keep the stops here. And so these stops are movable, and you can move them left and right, and then they can hit this centerpiece and basically use it as a stop for the end of a cut. I don't find these that useful anyway, and with the DRO, I'll be able to precisely say, oh, I need to stop the cut at this measurement here. So I think I'm going to take the easier path and remove the stops and this bracket here and mount the DRO using kind of the same hardware on the front side, and then make my life quite a bit easier. So this will sit in the middle, mount down here, this will mount to the scale, to the table up here, and then should work out just fine. So earlier I mentioned making the wrong parts fit, and that's exactly what we're going to do with the mill again here. So this is a dovetail nut that formerly held in the X-axis nut, and I figured it would be metric because this mill's made in Taiwan, but it's actually quarter 20 SAE. The universal linear scale, though, is slotted for 6mm, which is just a little too small. So we're going to use a 1/4 inch end mill here and open this up. Now we just got to do that 3 more times. All right, so now I'm working on the bracket that will attach the fixed portion of the slide. And this is one that came with the kit. And all I've done here is I've made a rough cut with the bandsaw to get most of the material off. I'm going to go through and make a cleanup pass with the end mill, and then I'm going to drill these 2 holes to mount it to the table with some low profile 5/16. Once again, Taiwanese mill, but 5/16 hardware in this spot. So I've got the X-axis linear scale mounted here temporarily. My bracket here works just fine, but I need to get some longer bolts and machine some spacers for the back of this. So these are in here maybe 1.5 turns, and I've got some spacers on the back here which are just some nuts, but I'm going to turn some on the lathe to fit that with the longer bolts when I get those. But I went ahead and plugged in the display just to do a quick function check. And as you can see, when I crank this wheel here, the X-axis starts to move. All right, as a quick gut check, let's see how this compares to the dials. So I've got the X-axis zeroed out here. I've got this dial here on 0 on the wheel, and each one of these is 1/1000th of an inch. Full revolution should be 100,000ths of an inch. So 0.1 inches, if you will. So let's move it 10 thou and see what the DRO says. So there's 10 thou, right? So the dial's pretty close. Let's go 20. 50. Once again, with the dial, you're trying to line up, 2 marks visually, whereas this, reads it electronically. 75 thousandths there, and we'll come all the way back around, and it should be 100 thousandths, so 0.1. So it looks like it checks out thus far. All right, so mounting the display here, I'm right-handed, so it's more convenient to have it on the right side of the machine, and it's got to be up high enough to clear the quill here. So really, there's only one place it can go, and that's pretty high mounted up on this side to clear that, or you got to mount it substantially lower, like way down here on the machine, which will be in the way of chips and slinging oil and whatnot. So up here is where it's going to work the best. To mount it, it just comes with this bracket here, and I'll just have to drill and tap a couple holes into the side of the machine here to mount it. All right, so it's time to install the Y-axis here, and say hello. So what I think I'm going to do is I'm going to take the linear scale like this. I'm going to drill and tap it into the base on the ends, and then all I have to do is connect the cross slide up here. Let me take this crank pulley out of the way. Connect this cross slide from here down to this piece, and then as the cross slide moves back and forth, this will move back and forth with it and give me the readout. One thing I want to note is these linear rails have these seals, and the seal kind of separates when the sliding piece slides through them and then kind of close up behind it. So I'm trying really hard to keep these on the bottom just to keep debris, oil, metal chips, everything out of them. But you could theoretically mount it straight up, and that would make it easier in some ways, but then you have to worry about debris getting in there. They do include some covers for these if you decided to mount them this way up, but I think it's just easier if I figure out a way to mount them, open end down just to keep the debris out. The mystery aluminum from this Chinese kit is not what I would call clean metal to weld. So looks kind of ugly, but it'll be on the back side, so I'm not terribly worried about it. All right, so I've got my bracket arm here welded on the back side. I've got it snugged up here, just finger tight with a couple bolts into the slider. And I've got a couple washers here just to give me some standoff, make sure this isn't dragging. And now all I have to do is transfer punch this into the end here and then drill and tap a couple holes. Well, unfortunately I broke my pilot bit off in this hole. So I'm going to try to weld a nut to it and get the pilot bit out. Otherwise we may be just attaching this with one bolt only. Well, got part of the bit out, but not enough. Guess we'll have to drill another hole, because that one's not going to work. So now we have X and Y on our digital readout. So let's do the same check we did on the X-axis by rotating the Y-axis one full revolution and see if we show 100 thousandths on the DRO. So that should be 20 thousandths thereabouts. So 19.6, 50, 75, and 100 thou. So looks like the DRO is reading properly. All right, so now that we've got the X and Y axis DRO installed, it's time to do the Z axis. The Z axis on this, you can have a standard quill like a drill press where you can rotate down, or you can lock it and have a fine down feed here. The problem is there's a lot of backlash once again in the dials here to see that, and then there's no repeatable stop, if you will, if you want to set a consistent depth. So if I wanted to make, say, 3 grooves and have them all the same depth, there's not a great way to make them all the same depth accurately, I should say. This depth stop here, you can adjust up and down, and theoretically use this to see, but there's a lot of slop in that, and it's not great. So once again, we're going to install another linear rail here. So I've removed the original Z stop from the mill head here, and where it used to mount, I have bolted this chunk of aluminum that I cleaned up both sides and bored a hole through. To the top of that, I'm going to mount this piece of aluminum channel. Now this is just a piece of industrial scrap I had lying around. It's got holes drilled in the sides, which won't really bother me. But that's going to get welded to this plate that I've just now here added. So when I move the Z-axis down, this will move with it, and I will be able to mount this, the linear rail here. Once that's mounted there to the side, I can fix this piece down here onto the side of the mill here, and then as this goes down, this will go with it. So I got my plate welded onto my piece of channel here, and I went ahead and welded up this extra hole down here and the hole down here, because that's where I need to drill and tap to mount the linear rail. So as you can see, the linear rail is going to take up this full length, and I need to drill and tap there. So I'm going to do a quick cleanup pass with an end mill, flatten that out, and then drill and tap that to mount this guy onto it. All right, so here I've cut out a pretty simple bracket out of some aluminum, and now all I have to do is drill and tap a couple holes here on the side of the mill to mount this piece while the rest of it moves. So now that I've got the DRO installed, I want to give a quick demonstration of how it makes things faster, easier, and more accurate at the same time. So I'm going to clamp up a chunk of 1-inch rod in the mill vise, and what I'm going to do is, it's not even on the end, so the first thing I want to do is I want to true up the end, and then I want to put some wrench flats on it so that it be 3/4 inch wrench flats. So across these flats, when I'm done, will be 3/4 of an inch. And it'll look kind of like this on the end up there from look at it. And so I want the wrench flats to have at least a flat of 1/2 inch. So here's the 1-inch rod in the mill. First thing we're gonna do, like I said, is we're going to face it off. All right, so now that our rod is faced off, I'm gonna zero the x-axis because that's the end of our rod where we just cut it off. All right, now the next thing we need to do is we need to find one edge, and generally speaking it's easier to find the edge closest to you. So one way to do this is to use an edge finder, but since I'm doing this just quick and easy, since we have our 0 on the end of this, all right, and I want a 1/2 inch wrench flat, I know I have to go this way. I have to move the workpiece this way, 1/2 inch plus half the width of my cutter, which is 3/4 inch. So I'm going to crank it over. So it's 1/2 inch, but we need to go 1/2 inch plus half the width of the cutter to get the center line the same place. So 750, and so that should give us a 1/2 inch flat on the end. So now, to find the edge, I'm just going to eyeball it a little bit and then go until I hear it cut. Alright, so there we're just pulling a chip. So now I'm going to zero the y-axis. We're just pulling a chip. So now I know I need to make passes to cut a 1/8 of an inch off of this, so 125. And since this is aluminum and a big end mill, I should be able to do that in just a couple passes. So we'll make our first pass at 50 thou, 50 on the Y. So we're gonna go back to 750 on the X to go back to where I started this cut. And now we can go in another 50 thou. All right. Back to our 3/4 inch, our 750 dimension on the X. So back to 750 on the X. And now we're going to make our final pass. So now we're at full depth on our cut there because our Y is at 125. So to get a 3/4 inch of stock left in the middle, we need to go a full 3/4 inch plus the whole diameter of our bit because we're going to be cutting on the other side. So we need to go, that's a 1/2 inch bit, so we need to go 1 1/4 inches to the other side. So to make that easy, once again here, because I know I need to go 1 1/4 inches, all I have to do is hit Y0 again. And so now I know when I go over here, I just have to go to 1.25. So that's going to be my final depth of cut. But I don't want to cut that. I want to cut in increments. How do I know where to stop? Well, once again, I go back to the 3/4 inch on the DRO. Since I want to do this in roughly 50 thou steps, I'm going to back this out. Okay, and I've stopped there at my 750 dimension on the X. So that's going to make both of my wrench flats even amounts from the end of the rod. All right, stop there at 750 again, like that. And we got 50 thou to go in depth of cut. All right, so there I've stopped my cut on that side, and I'm right where I want to be. I'm 750, 1.25 inches. Need some deburring with the file a little bit, but overall, we've got nice wrench flats on both sides. Hope this focuses, but our wrench flat should be 750. Looks like there's 751, 752, so may need a little bit of file work there to deburr them because there's still some burrs and unevenness on them. But that's pretty close there, not bad at all. But I got nice even wrench flats on both sides. So here's my round piece and a 3/4 inch wrench. So 751, pretty dang good. So thanks for watching. Please like and subscribe. And if you have any questions about the DRO or anything I did or what else it can do, post in the comments below.